All right, this is a little video going through our first physics experiment, a force table experiment. And for this experiment, we're going to be using this force table here. The force table is set up with these strings and little pulleys. These pulleys hold these little hangers for masses that we're going to use. And the pulleys are in different positions around here. You can loosen them up and move them around here and there to different places, different angles around this table. And the idea is that we want to set things up so that this little ring is perfectly centered in the middle, in the middle of this table. So it's not tilted. You can see right now it's tilted way over to one side. We want this little white ring to be perfectly centered in the middle. That's our goal. And to do this, we're first asked to take a set of masses, of mass for A that's given at angle 0. We've fixed this at exactly angle 0. Actually, it's not quite there. Let me make it perfect. Try to make it perfect. Just a second. There's a little tiny notch right where the angle is labeled. You may be able to make that out in your video, but there's a tiny notch there. And so, all right, that's perfectly centered. So this first one, this is our mass A that's going to be here. This will be B, and this will be C. And for the first experiment, we've been given our mass A should be 70 grams. Angle B should be 100 degrees up from here, which means angle 260 on here. And angle C should be 110 degrees up from 0. So it should be right here. So I'm going to start by getting those angles correct. And let's see, going to this angle C was supposed to be 110 since I'm over here. And I'm going to line up that little notch right there with the line we want and tighten underneath. There's a screw underneath to tighten. And for 100 degrees, again, that's angle 260 over here. I'm going to line this up and tighten it down, almost, there we go, all right. So those are our angles for this first one. And what we need to do now is put 70 grams on this string. The hanger itself is 5 grams, so we need to add 65 grams to that. In this little container, we have weights. These big ones are 100 grams each. These medium-sized ones are 50. So if I add a 50 down here, that gets us up to 55 for mass A. And I need to get to 70 grams. So let's see, 55. These down here, there's some 20-gram weights in the middle. These are 10-gram weights. So this goes, that's 55, 65. And then I need a 5 gram to get up to 70. This should be a 5-gram weight, 70. So our mass A is correct now. So what we need to do is figure out what masses to hang on these two hangers so that this balances perfectly in the middle like that. That's what we need to do. We may need to do some trial and error adjusting. I don't know, let's see. I'm guessing, since these are sort of a flat angle compared to A, since these are both pretty flat, I'm guessing these are both going to need to be pretty heavy. So I'm going to start them both at 100 grams and see where that puts us. 100 grams here. We may need to go back down. Technically, I'm starting it at 105 grams because the hangers are each 5 grams. Make sure this stays on the pulley. It's really important. Okay, yeah, you can see at 100 grams each, or 105 grams each, this is still, I still need more pull on those. I need to pull them harder to balance it out. So I'm going to try adding another 20 grams to each of them. See what that does. So that'll bring each one up to 125, including the hanger. We'll see what that does. Okay, that's not bad. If I increase this one a little, yeah, okay. I'm going to try adding another 10 grams to each of them. 2 things here, 10-gram masses for each one. So that'll bring them up to 135 each. This might overshoot. We'll see. 135 each. Let's see, if I pull this, what I'm doing to figure out what I would need to do, I'm pulling on each one a little bit. If I pull this a little, make this a little harder, It's going to be close. We're still not quite balanced there, but it's close. I'm going to put another 5 grams on that one and see what happens. So another 5 grams here. No, let me put another 10 grams over there. Do I have another 10 gram thing? Oh, you know what? I'll take off a 10 and replace it with a 20. Right, there's a little bit of a game here of getting the right amount of stuff on each one. Okay, that's heavier there now. If I pull this one alone, that's going to come really close, actually. Let me see if I can put 5 grams on this one. How'd that do? That might be a little too much. Well, I have here some 2 gram. I think this is 2 grams. Yeah, these are 2 gram weights. Let me see what happens if I put just a 2 gram on this. No, that hasn't done it. Another 2 grams. Oh, look at that. How are we doing? Let me take this little screw out so we can see better exactly how this is lined up. I said, maybe I shouldn't be taking this out. Yeah, okay, never mind. That might be structural somehow. Well, okay. I think you can see from up above just fine. And we're not quite, well, if I try to look in here, getting my top of my head there, if I try to look in here, I think I need a smidge more weight on this side. I'm going to try putting 1 gram over there. I've got a few 1 gram pieces here, these plastic 1 gram pieces. Add 1 gram over there. Oh, how's that? Oh, that's not bad. That's not bad, though. Now it's a little far on that direction. If I added 1 gram over here. So you can see this is getting very fiddly. And trying to get it perfect is going to be a hard job. If I slow this down a little. I think I just keep adding little bits and pieces here and there, right? You have to fine tune a lot for this. Okay, that's getting too heavy. I'm going to take this 1 gram off and see if I can put just a ½ gram over there. These little ½ gram pieces. You get the idea that there's a lot of fine tuning in this to get it exactly right. ½ gram. Look at that. That is very respectable. So if you look at that circle, your camera's a little bit off center, which means you're looking at a little bit of an angle. From looking straight above, that feels really good to me. So, all right, now I've lost track of how much weight was in each one of these. Now, the one other thing we do need to figure out is our uncertainty in these measurements. I'm going to write down these amounts, first of all. I'm going to take notes on this. So for A, this is for part A of the whole thing. And my mass B right now, that's this one, is 100 plus 20 plus 100 plus 20, so it's the 5 grams for the hanger, 105, 125, 135, 6, 7, 8, 9, 40. So this is 140 grams right now for mass B. 140 grams. And mass C right now is at 5 for the hanger, 105, 125, 145, 146 and a half. 146 and a half. 146.5 grams. That's what we have. But now there's a question of how trustworthy we feel these numbers are. How is it? Because you saw I was fine-tuning it. What, for example, if I put a 1 gram mass on each one of these two things, they're pretty well balanced. But if I put a 1 gram mass on each one and let it shake around for a second, here's my other 1 gram mass. How does that look? Honestly, that still looks pretty good to me, right? It still looks very centered. If I put even another 1 gram mass on each one, oh, come back, ah. If I put even another 1 gram mass on each one of these, I'll bet that's starting to look a little off center. So, but adding 1 certainly didn't hurt anything. So adding 2, well, maybe it was an issue. What if I took off? This is back to our what we'd written down. I just took off my extra masses. What if I took off a gram from each of them? If I just took off one of these, okay, this one is 1 gram. I'll just take it out, and I'll take out a gram from the other side as well. If I now let this stabilize a little, honestly, that's still looking pretty good. I'll bet if I took another gram off of each one, I'll bet it wouldn't really work as well. That's what I'm thinking, is that taking another gram off. Yeah, you know, so here's a ½ gram added to this one again. How's that gonna look? Stop wiggling, stop wiggling. Yeah, no, that's too much. So but I think if I were gonna say this, if I were gonna put my estimates on, I think that I have an uncertainty of maybe plus or minus a gram in each one of those. And that might be an underestimate, but I'm just gonna say plus or minus 1 gram for each one of those measurements. So mass A was given as 70 grams, mass B is at 140 plus or minus 1 grams, and mass C is at 146.5 plus or minus 1 grams. That's what I came up with for this. All right, so that was the first part of the lab, and there's analysis to do after that. But the second part of the lab, I'll let you do the analysis. Yeah, all the rest of the analysis is just that. And yeah, next up, I'm supposed to take these off, reset these masses, and instead, for the next part, we're given 3 specific masses to put on, and we're supposed to figure out what the corresponding angles have to be. So for this next part, mass A is given as 110 grams. So 5 for the hanger, plus 100, plus one of our 5 gram discs. That is 110 grams for mass A. For mass B, it's supposed to be 70 grams. Remember, B is over here. We got 5 for the hanger, plus I'll add one of these 50s. So it's 55. Oops, I'm losing my pulley. 55. Can't put a 20 on. 55, 65 with a 10 gram, 70 grams. Is that right? 55, 65, 70 by adding this 5 gram piece. 10 and 5, yep, good. So 70 for that. And mass C is supposed to be 85. So here I have 5, 55. I'll add a 20 to get me up to 75. And then grab a 5 gram to make it 85, or to make it 80 rather, exactly 80. All right, so I'm now at the point where I have 110, 70, and 85. And my goal is to figure out how to balance all of these by setting the angle properly for this, finding the right angle to the angles. We're going to leave this one at 0, and I want to find theta B and theta C that make this work. So looking at it, it looks to me like I need to pull it more this way. That's going to help a little, but now it's way off over here. Pull it more oh, look at that. All right, all right. You see what I'm trying to do here? It's pulled one way, it's pulled sort of the other way, maybe somewhere around here. All right, tighten that up. Now I'm going to adjust this angle again. Oh, hey, oh, yep, getting there, getting there. Okay, here's what I'm going to do. I'm going to go like this. Then I'm going to adjust this one again. trying to get my angle to line up. Oh, where are we? I'm trying to just, remember, I can't adjust the masses anymore. The masses are fixed numbers. Oh, this needs to slide a little too. I've got to make sure my strings are in the right places along the ring. Oh, almost. Close. Tighten this down. What about this one? Oh, hey, that's getting very close. And moving this over a little. Oh, that's nearly it. Again, I should be looking from straight above, and you're close to that, but not quite straight above. I'm working on this. Oh, shoot, I moved it too far. Okay. I gotta move. You can see this is like just a process of really painstaking fine-tuning and adjustment to get it to come together really well. Oh, hey. Almost. I'm feeling pretty good right here. Okay, well, I tighten it down and it goes a little off again. Let's see. Oh, we bumped it. Okay, that's pretty good. So let's look at what angles we come up with. Angle A is still 0. Angle B is showing up here. Again, I want to read from this little notch right here. It looks like it's here at 225, 26, 27, 29. If I were going to read this carefully, I'd say 227.8 or something. So I'm just going to write this down. Theta B equals 227.8 degrees. And theta C, if I'm writing that one down, over here seems to be at 141 exactly, 141.0 degrees. So if I really want to get this right, if I really want to get a sense of my uncertainties for these, what I should do is I'm going to just loosen this, mix it up again, put it somewhere completely arbitrary, and I'm going to try to do this again, kind of sort of from scratch, to see how reproducible those numbers were that I just came up with. Honestly, I should have done that with the masses too. I'm just apparently lazy. So, all right, doing this again. Let me just do this again and see if I get the same numbers or something a little bit different. So, here's this. I know they've got to be closer in. Close. And oh, hey. If you try something several times, if it's a very fiddly procedure, it can be very useful to try it several times and see how consistent your numbers are. That's a big part of doing science, is multiple trials, repeated trials. That's not bad. I'm going to tweak this just by like hair's breadths. Trying to get this a little. That looks good to me. Let me try this. This one is at 140.0 really. So my theta C is 140.0, and my theta B, looking at this carefully, come around to this side, looks to me like I see 225, 6, 7, 227.7. Oh, look at that. Wow. 227.7 degrees. I'm going to do it one more time just to get a range here. I should have done this multiple times for the other one as well, come to think of it, just to get a sense of what my uncertainty was. Okay, let me try again. Start with this. Try to get this moved to, okay, I need to get them both down to get any sort of sense of where to go. No. Gotta try this again. No, this is too far in this direction. I need to do more. Here, let's see. You can see this is always a fiddly task, getting this exactly right. But the key idea is, once again, don't do that. The key idea is that you want to just see how repeatable your measurements are. You just keep adjusting to see if you can get it just that little bit better at every given moment. Oh, close. Let me try this. It really is fiddly. It really is something trying to get this just right. Now I've got to get this a little lower. And that second time went really fast, and this time isn't quite as slow as the first, but how can I fix this? I feel like I need this to be a little stronger. I need to do a smidge more to my right, and then try this one. Oh, that's not bad actually. Let's see. This maybe isn't too bad. Okay, that almost has it. Let me tighten you, bring you back over. That's looking, bumped it. That looks pretty good. Let me try these. This is still at 0. This one is at 140.1. 140.1 for theta C. And for theta B, I'm getting, let me look from this angle, I'm getting 227.9? All right, yeah. Look at that. So looking at my data, looking at the results that I've come up with this, it looks like maybe I would report my theta B. That's a really tiny uncertainty. I would say 227.8 degrees plus or minus, honestly, 0.1 degrees based on those 3 data points. That's a tiny spread. The other one is more like what I would have expected. Theta C is 140.4, call it, or 140 point, and I should be able to average these. 0 plus 10 plus 111 divided by 3. Yeah, call it 0.4. 140.4 degrees plus or minus 0.5-ish. 0.5 degrees. So that's my estimates. Theta B is 227.8 degrees plus or minus 0.1 degrees, and theta C is 140.4 degrees plus or minus 0.5 degrees. That's what I'm coming up with for my estimate for those uncertainties. In A, I probably should have tried it again from scratch rather than just messing with it a little, but we've got some estimated uncertainties there. I hope I haven't underestimated the uncertainties too much. But that gives you data to work with, and from here, you should be able to then analyze that data according to the lab manual and figure out what's going on. The idea is going to be that you'll convert each one of these masses into a force, because the force of gravity is mg. G is 9.8 meters per second squared. These masses in grams. Remember, m is usually in kilograms in SI units, so you'll have to divide by 1,000 grams per kilogram to get to the number of kilograms. So you'll find a number of force in newtons for each one of these. I guess a 100-gram mass should give you about a 1 Newton force. So you'll get forces in newtons for each one of these, and your goal then is going to be to draw a triangle, filling a sheet of paper, to draw a triangle that looks rather a lot like this one. It's just big, 1, 2, 3, and you're going to start from here, and you're going to do vector addition, your force vector at a known magnitude and angle, and you'll have a little fuzz in the magnitude, right? You'll have some uncertainty in how far you draw it, and then this with some uncertainty in how far you draw it, and you'll want to see where that takes you, whether those add back up to 0, because these forces should balance out perfectly, as you see here. And you'll do the same thing for B, where you know the 3 force magnitudes, and now you can put the angles together and see if they match. That's where this is going to go. And then part C, you use your data from B, and you'll do that with vector components. So that is how this is going to work. I hope that that was clear enough for you to understand how the lab worked. Ask me if you have questions.